Hello everyone, welcome back. This is part 2 of Virtual Cloud Network Level 200 course. I am Harshit Agarwal, part of the Technical Enablement team at OCI, and here I'm going to talk about transit routing. So let's start with understanding how transit routing came into picture and where is the need of transit routing. So in general, most customers deploy a hybrid cloud environment where they extend their on-premises data center network to OCI, and to establish the connectivity between on-premises and OCI platform, they use either the Fast Connect or an IPsec VPN connection. Moreover, if the customer has organized or wants to organize resources in multiple VCNs to meet their governance model and regional presence, connecting all those such VCNs to on-premise network can be a real challenge. So your only option would have been either to have a fast connect or IPsec connection terminate at each of these VCNs, though that means that you will incur significant cost for multiple fast connect links, and you have the operational burden of provisioning a new fast connect or IPsec connection each time you add a new VCN to the region. So VCN transit routing offers an alternative. This solution uses a hub and spoke topology where a customer dedicates a hub VCN and connects it to the customer's on-premise network using a fast connect or let's say an IPsec VPN. With this solution, you no longer need to attach a DRG to each of your VCNs to access your on-premises network. You only attach a single DRG to the hub VCN and allow resources in the spoke VCNs to share the connectivity to the on-premise resources. Building on the concept of VCN peering that we learned in part 1 of this series of VCN 200 course, the other spoke VCNs are paired with the hub VCN. The traffic between the on-premises network and the paired spoke VCNs transit through the hub VCN, and only a single fast connect or IPsec VCN is required for the on-premises network to communicate with all the spoke VCNs. This solution also introduces a key construct in the OCI virtual networking model, that is route table association with gateway. So now the customers will be allowed to associate VCN route tables with gateways just like they would previously associate the route tables with subnets to establish transit connectivity between the multiple networks. So the customer associates a route table with local peering gateways and configure route rules to direct the on-premise traffic to the DRG. Similarly, the customer will associate a routing table with the dynamic routing gateway and configure route rules to direct customer traffic to each of the local peering gateways. DRG will then advertise the hub VCN CIDR and those CIDRs configured in its route table to the on-premise network. And from this point on, the customer's on-premise private workloads can communicate with customer workloads located on both the spoke VCNs. Traffic to the spoke VCN will be sent via the fast connect peering connection to the DRG in the hub VCN. A DRG will then direct the traffic to the corresponding LPG in the hub VCN. So this is one use case which transit routing solves. Building on this capability further, we can deploy a network virtual appliance such as firewall or IDS, IPS, which is intrusion detection or intrusion prevention system in the hub VCN to enable things like centralized policy enforcement or centralized inspection of all traffic between the on-premises network and the spoke VCNs. So with VCN transit routing through a private IP, we can add routes to the route tables associated with the dynamic routing gateways and local peering gateways to redirect their traffic to a private IP within the hub VCN. To achieve this, we associate route tables with the hub VCN's local peering gateways and the dynamic routing gateways. set up route rules on the route tables associated with the DRG to direct the Spoke VCN's traffic to the private IP address of the firewall's untrusted interface. Similarly, add route rules on the route tables associated with the local peering gateways to direct all on-premise traffic to the private IP address of the firewall's trusted interface. With that being set up, your on-premises workloads can now communicate privately and securely with workloads in the Spoke VCNs. Traffic to the Spoke VCNs is sent via the Fast Connect connection to the DRG in the Hub VCN, and the DRG then directs the traffic to the private IP address of the firewall virtual appliances for inspection. This inspected traffic is then redirected to the corresponding local peering gateway in the Hub VCN. So up till now, we have seen association of route tables with dynamic routing gateways and local peering gateways. With this feature, you can now associate route tables with service gateways. What this enables is that let's say your on-premise instances with private IP addresses can now access the Oracle services in the Oracle Services Network via Fast Connect or VPN Connect links. And your on-premise instances will no longer need a public IP address or a NAT or a Fast Connect public peering to access the critical Oracle services like object storage or ADW/ATP in the Oracle Services Network. The way you achieve this is by including an OCI service gateway in the Hub VCN. Then associating a route table with a service gateway and configuring the route rules to direct all response traffic to the DRG in the Hub VCN. Then you configure the route rules in the route table associated with the DRG to direct Oracle services traffic to the service gateway in the Hub VCN. DRG will advertise the Hub VCN CIDR and those CIDRs configured in its route table to the on-premises network, and from this point on, the customer's on-premise private workloads can initiate connection to Oracle services, and the traffic to the Oracle services is sent via the Fast Connect peering connection to the DRG in the Hub VCN. DRG will then direct the Oracle services traffic to the service gateway in the Hub VCN. So this brings us to the end of our part 2 on transit routing. I will see you next in part 3 of this series on VCN 200 course, where we're going to talk about deploying virtual firewalls on OCI. Thank you.